Hi everybody, so these things, tins of beans, actually the tin, what you can't do with an empty tin probably isn't worth doing. I mean, you can do all kinds of things with them. People making Stirling engines, rocket stoves, all sorts of stuff. It's incredible, really. And I came across this guy called M.G. Nasir who made an engine out of it. Now, I can't really claim to have made this engine because it wasn't me, it was this guy and I'm just copying him. I can't even really claim to have found it because a friend of mine said, "Hey Rob, have you seen this?" But I loved the engine and I thought it was such a simple engine that it was worth the trouble to see if it actually worked and whether we could build it or not. And what you need is 3 empty cans of beans. So you get 3 empty cans of beans, or full ones, have some beans on toast and wash them. And on the first one, you do absolutely nothing. The second one, you put a lot of holes in the bottom. And the third one, you stick a balloon on top and a big hole in the bottom. That's all you have to do. I mean, that is the simplest engine I can think of making. And so, we're going to make it. So let's get this emptied out and get those things done. There you go, 1,000,000 holes. I mean, it's not really critical, just make it into a sieve. And the second one goes on the first one. Now the third one, cut a big hole in the bottom. I used a hole saw. You could use a can opener, anything, just cut a big hole in the bottom. These two need JB welding together, so put some JB weld on that. The reason for that is they have to be heat resistant, and JB weld's going to be awesome for that. Okay, so once you put the JB weld on, add about 2 millilitres of water into that bottom can. Then fill that centre can with something, and that's what I used. It's gravel from a fish tank actually. It's about 2 to 3 millimetres in size, and that's what you fill the centre one with. In our third can with the hole in, we JB weld that onto there. Leave the whole thing to set. When that's set, grab yourself a balloon, stretch it over the top of the last one. Oops. Tape it down, glue a nut on the centre. Get this thing going, you'll notice I've drilled a little hole there and put a bit of tape over it. You heat it on the heat. Then allow that to expand a little bit, open that till it flattens out, and then close it up. When you do that, it's ready to go. Isn't that amazing? So there are no moving parts in this. Wow. Okay, so the operation of this is pretty clear. You'd make this a linear generator. Apparently, it works better if you put more water in, then there's a lot more force in here. So I guess we could drive lots of things with it. I'm tempted to connect it up to a piston, in which case it would be a standard steam engine. But actually, that's really quite impressive. Look at that bad boy go. So just to recap, it's 3 bean cans. Bean can 1 has nothing done to it. Bean can 2, the bottom is filled full of holes with a drill or a nail and then filled with 2 to 3 millimetre fish gravel. Can 3 just has a big hole chopped in the middle of it, and then the whole lot's joined with JB weld. We put a diaphragm on the top with a nut in the centre, and then in this can drill a small hole, 1 2 millimetres, so that you can even out the pressure. Now I can't believe how simple that was. No moving parts, no engineering. Anybody could do it with a nail and 3 bean cans and a balloon, and we have here, well, a generator. It's certainly a motor. Now I'm not sure what kind of motor it is. It kind of operates a bit like a 3-piston Stirling, but of course it's using steam, so it's maybe half a steam engine, maybe half a Stirling engine, but certainly an awesome engine to build, because that, I mean, it's really something anybody could build. You can see it running, and it's running on that T like that. So in the video I said apply heat. Now somebody posted, "That's great, Rob, when you're actually doing this every day, but not all of us do this every day." And I thought, yeah, that's really my bad, so sorry about that, guys. But I do get excited by things, and sometimes I rush into them a little bit. And when this started working, I found it very exciting, so I apologise for that. When I say heated, what I mean is apply heat to the bottom of here. Now it's a low thermal difference engine, so even a T-light's going to be able to run it, but of course the better your heat, then the better it's going to run. And remember we said put more water in there, it will vibrate much more deeply. It's barely moving, because it's a T-light, but we can get some really great action out of this. Now, when I say heated, of course you mean T-light, hot plate, fire, rocket stove, Bunsen burner, whatever you want to run it on, you're going to be able to run it on by applying heat at that point there. Now what we're going to do is going to break this thing apart, which is why I wanted to run it first off. We're going to break it apart so we can see much more detail. So before I take it apart, I just want to illustrate something to you. I've got a hot plate here and it's about 250 degrees centigrade. Now, the more heat difference, the more power. So if this is 250 and I can keep this at room temperature 20, then it's a greater heat difference than I had it on the candle, because the candle doesn't output enough heat. It starts by itself. See that? There you go. The candle doesn't output enough heat to match the losses. This is outputting quite a lot of heat, and so it's matching the losses and raising it, so we're getting a bigger heat difference. Now then, this actually was the work of Blade Attila and his friend Timsin. Now those guys, what they don't know about Stirling engines basically isn't worth knowing. I mean, you could write what they don't know on the back of a postage stamp and still have room left for your Christmas shopping list. It's astounding what those guys actually know. So this was taken from work that they did about 13 years ago. It's done by the chap I mentioned. I looked at him, he didn't remember it was Blade. Blade wrote to me. And if you're really interested in these kind of things, you need to jump over to those two websites. If you want to know where the websites are, both Blade and Timsin put a post, so just go through the comments, you'll see his name, click on it, you'll jump straight to either of those websites and you can check out the work that they've been doing. And the work that they've been doing is absolutely awesome, in fact. That's brilliant, and it's so simple the way this works. It's going to be a great thing to do. Really, with anybody. Now, I did it in a 3-can section. I did it in a 3-can section to make it obvious what each section does. But you don't have to do it in a 3-can section. You can do it in a single can as long as you have the 3 sections. Then you repeat those 3 sections and you'll be fine. So this can be done in a whole range of ways. I'm absolutely fascinated by this. I can see the use of it. I mean, the use of it is going to be in easy to build generation. Now this is not going to be super efficient, that's not the point of it, but it is super cheap, and that's the whole issue, is being able to build something that is super cheap and will do something. Now it's obvious how to generate from it. It's a linear generator. You just stick a coil there with a magnet on it. As that magnet moves to the coil, it's going to generate. I mean, I probably wouldn't put the magnet straight on there, maybe a push rod so you get further travel. But that is how you would work this. That's how you apply heat to it. The heat will, the amount of work it will do will differ depending on the heat difference, but any heat source at the bottom can is going to do exactly the same thing. Right the way down, look at this bad boy. I get that diaphragm movement at about sort of 3, yeah, about 2 or 3 distances of the nut that it was on. Anyway, it's going to go right the way down to a T-light where you won't get much power, right the way up to a heat where you'll get a lot, because you look at the travel. Because you've got a big heat difference. If you maintain that heat difference, you're going to get a lot of power. Now clearly, I'm just holding this can, so it's not very hot, but we could cool that section and then we would improve the heat difference. That's bananas. Let's take it to pieces. What a shame! One of the things I talked about was this hole here. If I open that up, we've got a little hole there. Tamsin tells me that if that hole is small enough, you don't need to put the tape over it. I've drilled about a 2mm hole, so it's a bit big. Now with that 2mm hole, what it does is equalises the pressure between what's inside here and what's outside. And you can see it with the tape covered. What will happen when they first use it is that will bulge right out. Just peel back the tape, it will sink back down again. Put it back on, it's a bit bulging too far, pull the tape a little bit. Then when you get it just right, and it only takes a couple of tries, it'll self-start all by itself. And you see, as we've adjusted the pressure now, then we can see that we're getting much greater. So play around with that pressure a little bit until you get the response to be something like this. And the way to play around with the pressure is dead simple. Just pull that off, put it back on again. When you get the pressure just right, then obviously the thing is going to, there you go, self-start and go crazy all by itself. So it's not difficult to do, but you do need to do it. And when you first see it bulge out, peel back your tape to let that bulge go away. And as you continue to play with it a little bit, and you'll set that pressure until you get a crazy response. When you get a crazy response, well, leave it alone. Okay, so we've talked about the hole, so let's take that off. Now we talk about this a little bit. This is an ordinary household balloon. Okay, it's the kind of thing you get for parties. I got it in red, obviously. Just cut that section off, and then you can stretch a diaphragm across it. And then I wrap it round with a bit of electrician's tape, just to stop it coming off. There we go. In the centre of here, obviously, is a weight. It's a nut. It's an M12 nut, as it happens, and it's just a mass that it can react against. I mean, if you're going to do something like a generator, then you don't need the nut, but you do need some way of attaching it. And a tap washer with a bolt through it, and then your magnet on that bolt is going to be just Jim Dandy. And then we have a look in here. And you can see it's just a big hole filled with gravel. This gravel is this stuff. This is used for the bottom of aquariums. Now I have a pet store near to me, which is why I got it. There's nothing special about it, apart from the size. Somewhere between 2 and 4 millimeters is what you want for an engine this size. If you use larger beads, like baking beads or marbles or something like that, it's actually too large to do its job, because this is kind of a regenerator. If it's too large, everything goes through too quickly and it just doesn't pass that heat or recondense the steam and allow the steam to drop back into the bottom can. It just doesn't do it, and so it's too large. So you need somewhere between 2 and 4 millimeters, and a ton of things will do. I've seen those glass beads, the little ones you make bracelets and necklaces out of for children. Gravel, which we've just used, and historically, so Blade Attila tells me, rice was used. Apparently it was called a rice drum. The rice would make it vibrate and make it hum, and that's where he found it from. Ancient China, I believe. He found it from that, and then the two of them worked on it for a while. But to be honest, any material that is 2 to 4 millimeters in size and has some mass is going to do this job, apparently. So that's all that is. I just bought that from the pet shop. Get some pea shingle, probably get some dirt and sift it. So as long as it's that size, that's all you're going to need. And this entire can, this one here, is filled with this stuff. Now I did try it up there, and it does change the properties. It actually makes it a bit deeper. I did try it down there, and makes it more shallow, so you get a higher frequency. So the frequency is going to depend on the depth of that, but just filling that can, it's just plenty good enough for your first try, or if you're doing an example of this. And then we can just empty that out. There you go, we can see it steaming away because we've just steamed it. Now we break this apart, which could be a challenge. I did get it apart, but it was a challenge. So, this top can, remember the balloon was stretched across there and we had our little hole in there? That's a top can. And as you see, it's just an unaltered can. I took the lid off, I emptied the beans, I washed it out, and I used a hole saw to make this big hole. Doesn't matter how big that hole actually is. It can be that size, it can be right the way up, you can use a can opener to open it. You just need a big hole where the thing can go from one side to the next side and hit that diaphragm that we've got fixed on there. So that's the top can. The middle can, again, take off the top, empty out whatever it is in there, give it a wash. And in the bottom, I drilled a load of holes just to make it a sieve. Those holes are small enough so that the gravel won't drop through. That's all it is. As long as the gravel doesn't drop through, that's going to be fine. I mean, you could replace that just by cutting the whole thing out and putting a bit of mesh on there if you like. You're just stopping the gravel from dropping into the bottom can. That's the only thing. The third can has absolutely nothing done to it. I mean, I took off the lid, I washed out the can and did absolutely nothing else. And then in there, I put 2 to 20 millilitres of water. Anywhere in that range is going to be fine. It's going to work. Now, when I did it, of course, I'd already glued those together, and I glued those together because glue doesn't like wet surfaces. So if I'd put the water in here and got this surface wet accidentally, which would have been a bit of a pain, I'd have had to dry it, or I might not have noticed, and put a glue on and it wouldn't stick, all that sort of stuff. So I glued them together first, and then I poured the water in there, making sure it went to the bottom of there. But again, it doesn't matter that much if there's a little bit of water left in here. You want the bulk of the water to go in here, but it'll just drip through because you've drilled a load of holes. There'll be a little bit left in there, but big whoop. Now, in case you don't know, JB Weld is an epoxy resin. It's called replacement steel. It lasts to a very high temperature. I can't remember what the temperature is, but it's high. And it's a 2-part epoxy that you buy off somewhere like Amazon. You just order it from Amazon under the title JB Weld, which is JBWELD. You order it from there, you can mix it up according to the instructions, which is same part A, you have a centimetre, part B, you have a centimetre. It's equal amounts of part A and part B. Give it a mix together, wipe it along that surface, poke it down there a little bit, give it about 8 hours and it'll be rock solid and quite difficult to take apart and will last on that heat. So JB Weld's an awesome material for doing these kind of things. But again, you don't need it actually. You can just put tape around it. Now the tape will burn away and the glues will get soft, but it will do the job for a demonstration or one go at it. Something when you use that, it's much more permanent, okay? So that's why we use JB Weld. So there's just nothing to this, like I say. And I did it as a 3-can version so we could see the sections. We've got the water holding section, we've got the gravel holding section, and then we've got the diaphragm section. So we can put those 3 sections together. But there's no reason that those 3 sections can't be shrunk into 1 can, and you just maybe put a mesh in the bottom of the 1 can, or what Blade Attila did was he put another can in that can, so it held it off a little bit. Then he put a stainless steel scourer in there, and then a bit of a steel wool, and then he poured his gravel on top of that, and then he put his diaphragm on top of that. So there's no reason you can't shrink it down to 1 container if you want. We did 3 containers because it's very, very obvious what each of those containers is doing. Now, the way it works, well, Blade says it's a thermoacoustic engine, and I can believe that. I have my own ideas about how it works, really, but Blade is the god of all things Stirling, so I'm going to go with what he said. Well, basically, the way it works is obviously the steam is in the bottom here. Rather, the water is in the bottom. You heat the water, it turns it to steam, it drifts up there, makes the thing bulge out. Of course, what it'll also do is increase the pressure of the air in there, because we've now got steam in there taking up space, and so the air must go somewhere. It goes through this gravel. This gravel is a cold mass, and of course it's going to condense when it hits that gravel, and that will make it shrink back down again, and that expansion and constriction sets up a standing wave, a thermoacoustic wave, which is why the diaphragm is vibrating. Or at least that's the explanation I've been given. I'm not 100% sure about it, but it seems reasonable, and it was Blade who gave me that explanation. So hopefully there aren't any more questions about how to build this thing. I think I've been pretty much in depth about it, but it's one of those things where you may be worrying a bit too much about it, because it will work on any heat source. I mean, as long as you can get heat into the bottom here, remember that's the bit you heat right at the bottom, so you heat that bottom bit. It can be any heat source. It can be a candle, it can be a hot plate, it can be a fire, it could stick it on a rocket stove, you could turn a Bunsen burner on it if you wanted to. Any heat source is going to do it. Any material will do this as long as it's sort of 2 to 4 millimeters and it's a thermal mass, including rice will do it, glass beads will do it, this fish gravel will do it, or anything you pick off the beach or your house or your garden, give it a sift so you've got 2 to 4 millimeters, it's going to do that job. Of course, you might want to experiment with things to see what would do a better job. I think that's a brilliant thing, which is why I made it in 3 parts, because we can empty this bit out. Empty this bit out, put more stuff in, we can see if there's a better material out there that will give us a better amount of vibration in that membrane and more power in that membrane. So it's also something that you could experiment with. It's why I JB welded these 2 bits together first of all, then added this later. This, the job of this is stay cold. You could just tape that, which means you can just undo the tape and replace this stuff with your 2 to 4 millimeter bead of choice. Okay, I feel I've been very, very in-depth there. I hope I've answered everybody's questions. If you're interested in this, really do jump over to Blade Attila or Tim's Inn. Have a look at their websites, what they've been doing, because they've been doing some awesome work, and I stand in awe of those guys. We built what I called the strange engine. It was a strange engine because it has no moving parts. And somebody said to me, the diaphragm's moving, it's got a moving part. And I thought, well, okay. There you go, there's a hair, let's split that. Sure knew what I meant. It's amazing how you can build such a simple engine that will do something like that, because it's made out of 3 tin cans. It's a heat engine, okay? Basically a Stirling engine, actually. Stirling engines work better on heat difference, and of course we made it from 3 steel cans, so the heat is going to be transferred through the steel. It occurred to me, okay, why not take out that middle can and put a ceramic in there? And I've got a cup. If we put a ceramic in there, we've got a heat block. So now the heat can only be transferred in the gas, it can't be transferred by the steel. That should make it much more efficient. Okay, how do we go about doing that? Well, first thing, take your cup and drill a lot of holes in the bottom. So here's my 3 parts. An empty can with absolutely nothing done to it. Nil, nada, niente, nulla, zip, nothing. It's just an empty can. Then we've got our cup, and you'll notice cunningly a lot of holes drilled in the bottom with a tile drill bit. I think they're about 3 or 4 millimeters, something like that. That goes on there. I just put some electrical tape around that, like that, just to hold the thing together, because we're not talking massive temperatures, so the electrical tape's going to be absolutely fine. Bit of electrical tape to hold that together, and then fill the cup with this stuff. This is 2 to 4 millimeter gravel I got from a pet store meant for aquariums. I don't think there's anything special about it. You can use rice, you can use glass beads, you use anything as long as it's round about 2 to 3 millimeters in diameter. Fill your cup, and here's the final bit. The final bit is just a straight through can, hole in the bottom, bit of rubber on the top. Stick that on there. Now in the original video you had to put a little hole in here to equalise pressure. I found with this ceramic you don't need that hole. So let's put some gravel in here, tape that together, and then we'll run it, and I'm excited to run it. Okay, so there it is put together, and again, no moving parts. Except the diaphragm, and anybody who wants to point that out to me needs to get themselves a life. But there we go, it is an amazing engine. This should work more efficiently. It should be easier to get going. Now we had a great deal of trouble getting the original engine going on tea lights. Eventually we had to stack up a load of tea lights, and we got it barely moving. So to give an example of that, well, let's try it on a tea light. There you go. Somebody said to me, doesn't matter how you focus on it, I can only see a blur. And that's because it's moving so quickly. Now we barely got that moving when it was 3 cans, but now we put the ceramic in between on a tea light, we've got that thing actually performing very much better. That's moving a whole nut distance. It was barely moving on the other one. That's amazing. Another awesome question I was asked was, okay, do you need the water? And the answer is yes. I ran it dry and nothing happened. And then they said, okay, well, if you need some kind of fluid, what about one that boils at a lower temperature? So I've got here some methanol. It boils at 64.7 degrees centigrade. So theory, it should boil at a much lower temperature and we should be able to get the engine to move. So I'm going to fill this with about 8 millilitres. I mean, 8 millilitres, you spit more than that. So I'm going to fill it with 8 millilitres of methanol, and we're going to try and heat it. Now, because methanol is methanol and it's flammable, so another thought occurred to me. If that's going to be the case, we should be able to get this to run from the some hot water. The kind of water you'd make your tea from, so 60, 70 degrees centigrade, something like that. So let's go and boil a kettle, put some methanol in there, see what happens. It's actually running! Look, it's shaking the water and you can see it buzzing up and down. Wow! So I can put my finger in that water. So the water's probably about 60 degrees centigrade. The ambient here is 10 degrees. So we're going to be doing this from a 50-degree difference in temperature. That's moving about twice the distance of the nut. Wowzers! So 2 awesome improvements. 1, stick some ceramic in there to improve the efficiency. 2, use a lower boiling point liquid so it'll work at lower temperatures. But remember, it works off temperature difference. So we'll work at a lower temperature, but if the temperature difference isn't high, you won't get more power out of it. Anyway, the obvious thing to do with this is to turn it into a linear generator, and that's a magnet on there, a coil, and charge a phone. I've got some magnets arriving, so I will be making a linear generator out of it and use it to charge a phone. But my plan is to stick this on a heater so we can charge our phone from our heat. Now, efficiency of this is not going to be more than 37% because it's a Carnot engine, but efficiency of Peltier devices are around about 3 to 5%. They're rubbish. You can get higher efficiencies, but you're going to pay through the nose. Peltiers don't last above a couple of 100 degrees centigrade. They're just going to melt unless again you get the extra super duper ones, and they're again really stupidly expensive. So I think this compares more than favourably with a Peltier device, particularly when you may think it's made out of trash, which is awesome. So we'll get this into a generator form, we'll do a video on that, but I wanted to show you those improvements on the Strange engine. And people who are experimenting with this, if you put a ceramic in there, you don't need to do anything with the pressure, no little holes and no piddling around with it. It'll actually just self-start. Anyway, hope you enjoyed the video. Thank you very much for watching. Please do remember to like and subscribe.